Alright guys, today we're going to be learning about rational exponents. So in order to understand what rational exponents, we're breaking down the vocabulary into what a rational number is and what an exponent is. Rational number is a number that can be written as a ratio, meaning a fraction. So pretty much a fraction. Exponent. An exponent refers to the number of times a number is multiplied by itself. For example, 2 to the third, written like this, 2 to the third power, means 2 times 2 times 2, which equals 8. So today we're going to be having our exponents are going to be written in a rational number, meaning as a fraction. Okay, so that's what we're going to be able to understand at the end, what a rational exponent is and how it affects our numbers or our expressions. In order for us to also do today's assignment, and what we need to review is rules of exponents or laws of exponents, which you saw in Algebra 1. So here, the first one is rule of multiplication, meaning if we multiply two variables, let's say we have x squared times x to the fourth power, then we add their exponents. So that would be x to the 6th. Okay, so when we multiply variables, we add their exponents. Well, if we divide, then we're going to subtract their exponents. So it'll look something like this. And if we have x to the 1, then it'll give us x to the 2, right? If we're dividing, we subtract the exponents, and that'll give us our answer. Power to a power, if we have an exponent inside and an exponent outside, we're going to multiply those exponents. So a little example here would be x to the 2nd raised to the 5th power would be x to the 10th power. The power of a product rule. So we have more than one variable inside. Let's say x and y to the 2, and they're all being raised to the 3rd power. They each get a 3, or we multiply a 3 in. So that would be x to the 3 and y to the 6. Again, this is review. You've just seen this in Algebra 1. Now, if we have a fraction, then it's the same thing, except that the numerator and the denominator both get that exponent multiplied in to the other exponent. So we end up with that exponent that was outside to each the numerator and the denominator. Then anything raised to the 0 power is 1. It doesn't matter what you have inside. It could be a million numbers in here, but if you raise it to the power of 1, it just equals, to the power of 0, it equals 1. All right, negative exponents. If you see a negative exponent, it tells you I don't belong here. I belong on the other side of a fraction. So you move it to the bottom and now make that exponent positive, and you put a little 1 on top if there's nothing on top. And then this is the new thing that we hadn't seen in our Algebra 1 class is fractional exponents or rational exponents, which is what we're learning today. When we write it as a fraction, the top is going to be our power and the bottom is going to be our root. Okay? And to go back and forth to help you remember which is the top one and which is the bottom one, remember power over root. And we'll do some examples. So again, a rational number can be written as a fraction. So here we're giving two forms, and it's actually the same expression. We have x to the power of 2 under the root of 5. Well, I don't know how well you guys know about roots, so I'm just going to do a little example, starting with example 1. Well, you know what? Let's just finish this one. So in order to rewrite it, use the expression power over root. I'm sorry that this is not written well. Power over root. So the power goes on top of the fraction and the root goes on the bottom of the fraction. Okay. So just make sure you know how to write them back and forth. Now let me explain what each of these mean. By now we should know what a power means. So we have 3 to the power of 2. That means that 3 is being multiplied by itself twice. So 3 squared equals 9. Well, today, if I ask you what is the square root of 9, you can tell me that the square root of 9 is 3. These are perfect opposites of each other. Also, guys, the square root is the root of 2. We never put a 2, so it's just the basic is to understand that the square root is the root of 2. Now, when we do root of 5, means we're trying to find a number that was multiplied by itself 5 times to get the number that you're trying to get the root of. And we'll do some examples with example 2. I'm hoping you understand. So here in example 2, it's written as a rational form, meaning our exponent is in a fraction, and we want to change it to a radical form. A radical means with a square root. The square root is called the radical sign. So then it's power over root. So my power is 1, the root is 3. So 8 to the power of 1 under the root of 3, also referred to as cube root. And then I'm going to take off this little 1. You don't have to put an exponent of 1. If there's no exponent, you understand that it's a 1. Also, I don't want to write it because it looks like an 81. So that's how you write it as a radical form. Now, can we find the root of 8? Well, sometimes it's kind of hard to figure it out. The way I remember this is I just memorized it over the years. So 2 times 2 is 4, and times another 2 is 8. So 2 times 2 is 4, times 2 is 8. So then the cube root of 8 is actually 2. You know what? Let me take off this equal sign because I don't like how it looks. So I would just want to understand that if you multiply 2 times itself 3 times, you're going to get 8. So then that's why the answer here, the root of the cube root or the root of 3 of 8 is 2. Why? Again, because 2 times itself 3 times, or 2 to the third power, is 8. Okay, so we're working backwards. All right, now let's do something with more numbers. So we have 8, and remember, it's power over root, so it's raised to the 4 under a root of 3. Now, this is important. You can write it this way, or you can write it this way, where you write the root first and then the power outside parentheses. And I believe this is the best way to work it out. So there's actually a question in your assignment where it says, which one should you do first? And if you write it this way, you would do the root first, and then you would do the exponent. Let me show you why that's a lot easier. When you get the root of 3, the cube root of 8, or the root of 3 of 8, I don't know, that sounds weird. We actually did it over here already. This is actually 2, right? We just figured it out. It's the same thing, right? So I end up having a 2 inside raised to the 4th power. Now, that's a small number that we can work with. And we already did over here 2 times 2 times 2, or 2 to the 3rd power. Well, we know it's 8. If I multiply another 2, that's going to actually give me 2 to the 4th power, because I would end up having 2 times 2 times 2 times another 2 would give me 16. So the answer to 8 raised to 4/3 is equal to 16. And that's how you work it out. Now, let's look at this next one. First, we have to change it from a rational exponent to a radical form. So 16. And I'm just going to skip straight into the root. The root is 4. And the power is 1. And I really don't need the 1. So actually, we don't even need to have that. It's just a 1. So then the root of 16, the fourth root. Well, then I want to know what number multiplies by itself 4 times, multiplied by itself 4 times will give me 16. Is what we just did over here. 2 multiplied by itself 4 times will give me 16. So then the fourth root of 16 is 2. And if you're not sure, you could figure it out. 2 times 2 times 2 times 2. That's 4. Bring down that 2. That's 8. And bring down that 2. And that's 16. Okay, so that's how you could check it. All right, now let's do another example. This is a negative exponent. So we know because of our rules that I went over on the top. And please, guys, have this open when you're working this out. We have negative exponents right here. That if it's to a negative exponent, you're going to write it with a 1 on top, and you're going to move it to the bottom of a fraction and make the exponent positive. So here, this is make a fraction. The 8 is going to go to the bottom, and it's going to be raised to the 1/3, but now it's a positive 1/3. Then I can write it as a radical form, right? And it has a little 1, but I don't have to put the 1. And then we already did the cube root, or the third root of 8, which is 2. So my answer here is 1/2. Okay, and if you're not sure, we go back to example 2. Now again, we saw that the cube root of 8 equals 2 because of this over here. Not this bottom part, it's this top part here. Okay, so we already went over that. And that's why it's 1/2. All right, now let's do the next one. Again, it's a negative. So put it over a 1 over that. Now make it a positive 2/3. And then write it as a radical form. Remember, it's power over root. So the root is 3 and the power is 2. Again, it's easier. First, start with the root and write it this way. It's just, it'll save you so much time and heartache so you don't deal with such big numbers. Now you're trying to find the number that multiplies by itself 3 times to give me 125. So 5 times 5 is 25. And if I multiply it times another 5, it actually gives me 125, right? 5/4 is $1.25. So then the cube root of 125 is 5. But I still have that 2 outside. That one's easy because 5 squared is 25. So that is our answer, 1/25. All right, example 7. Now we have a power outside the parentheses. So both of the variables have to get that exponent. Both of the variables that are inside, both of the terms, not terms, both, whatever we have inside the parentheses, they both get that exponent. So now I can write it as a radical form. So root over power over root. Wow, I'm saying that wrong. So this is going to be under 3 and then squared. But with we can do the same thing for the x, but we cannot simplify it more than that. So I'm just going to leave the x as 2/3. Okay, that one, since it's an x, I cannot change that. But we'll see if we can simplify it in a little bit. Give me a second. Okay, let's do the number first. So one number multiplies times itself 3 times to give me 27. That's actually 3. 3 times 3 is 9, times another 3 will give me 27. So then the cube root of 27 is 3. But I still have the 2 outside. So that's going to be squared. So that's going to end up giving me a 9. Now let's see if I can do anything with this x to the 2/3. So we have power over root. So we have x to the 2 cube rooted, and nope, there's no way I can simplify this any further. Okay, so they might have your answer like this in your answer choices, or they might have it like this. Or they might write it with the exponent outside in parentheses, the square. Okay, so they all mean the same thing. What I mean is they couldn't write it this way also. 9 cube root of x squared. So they actually, all these three mean the same thing. I'm pretty sure they're going to write it this way though, because that's the easiest way to write it. All right, example 8. Example 8, all of these are under the root. So I'm going to actually separate them so we can break down each one. So I can actually split those. Since they're being multiplied, I can just split them by multiplication, but each under the radical sign there. Well, 4 squared, the square root of 4 is 2. The square root of x squared is x, right? Because they're actually the perfect opposite. And then the y cannot be square rooted, so we can write it this way, or we can write it this way, right? Okay. So again, if you're not sure, guys, remember that the regular square root really has a little 2 there. So if you want to rewrite it, it's going to be raised to a 1/2. And we're not used to that so much because we're not used to having a 2 there. It's just square root. So just know that if it's a simple square root, it's raised to the 1/2. All right, example 9. We have b to the 1/2 squared. Well, we know that b to the 1/2, as I just talked about, is b being square rooted. But then we're going to square it. Well, if I change this, if I use this as a radical form and use the property of exponents, where I have one exponent inside and one exponent outside, I actually end up having 1/2. I have to multiply the exponents times 2. Well, you can put a little 1 underneath and multiply across, which will give me b 2 over 2. Well, 2 over 2 is just 1. Well, we know that if there's a 1 there, we don't really even need it. We can just write it as b. So what happens when I have something squared and, I mean, the perfect opposite or the reciprocal of each other? Then they pretty much cancel each other out. So if I have an exponent like 1 to the 3rd raised to the 3rd power, they're going to cancel each other out, and that also will give me b. Same thing with b to the 1/4 raised to the 4th power. That will also cancel out and just give me b, right? Because they pretty much undo each other. All right, example 10. This is in radical form, so if it's given in radical form, then they want it in exponential. So remember, power over root. So the power is 7, so that goes on the top of the fraction, and the root is 4, so that goes in the bottom, and we're done. We can't do anything further with that. All right, example 11 and 12. I don't believe you're going to have these in your assignment, but I just wanted to show you something that's a little more extensive and challenge you a little bit with this problem. So if you have numbers like this, since the exponents are just with the variables, then I would start only with the numbers. So you have 2 times 3 times 4. So 2 times 3 is 6, times 4 is 24. So there's my number. I have answer choices. Usually I can at least cross out 1. Then I have x to the 2, x to the 1/2, and x to the -3. So when I'm multiplying variables, if we go back to our properties up here, okay, multiplication is adding. We add the exponents. Now this one is a little tricky because of the fraction, but we can still figure it out. So I have 2 plus 1/2, and they're not, actually let's leave the 1/2 towards the end. Let's do 2 plus -3, right? 2 plus -3 will give me -1. So then I'll have -1 plus 1/2, right? Because we have to add the exponents. So we would have x to the -1 times x to the 1/2. And well, we know that -1 plus 1/2 will give me -1/2, right? That's going to be x to the -1/2. So then that's going to be the x over here. They might just leave it as an exponent. You know, we never leave our exponent negative. It's going to be 24 x to the 1/2 on the bottom, right? Because if it's negative, it tells you I don't belong here. I belong on the other side. And then they might leave it like that, or they might rewrite it to the square root of x. And there's our answer. More than likely, they'll leave it like they'll go all the way to this one, just because it looks simpler. All right, again, remember, this is more just to challenge you. Here, it's kind of looks like a lot, but what I like to do sometimes when there's so many variables, I like to rearrange them, fixing the negatives. So if something is raised to a negative, it tells you I don't belong here. I belong on the other side of the fraction. So then I move them. So we have x to the 1/3 on the top, but then that x to the -2/3 is on the bottom. That's going to come to the top, right? If it's negative and it's on the bottom, it's going to move up. And then we have y on the bottom, but then we have y to the -3 on the top. So we're going to move that to the bottom. So now that we move the negative exponents to the opposite side, now they're positive, and now this will be a little bit simpler to work out. The y's will be the easiest one. If there's no number with the y or no exponent, it's an exponent of 1. And when we multiply the variables, we add their exponents. Now with the x's, it's going to be the same thing. So I'm going to have 1/3 plus 2/3, right? And it's just fractions. That's going to give me 3/3. Well, 3/3 is 1. 3 divided by 3. So we end up with 1x on the top. Now we still have a 6 outside. So we have to multiply that 6 or distribute it to the x. But I also have to distribute it to the y. And y already has a 4, so those multiply. And that is our answer. I know it was a little extensive, but that's just to challenge you guys. And that's it. That's all your notes for today.